Okay, so hello, my name is Anthony Cruz. This is Fluent Assignment 2. All right, so the first thing we're going to do in this assignment is we're going to open up our geometry. And as you can see here, we have our geometry. We're starting off with a 30-degree angle. So once we have our 30-degree angle geometry set, we go ahead and we generate it. And so also what you must do in your in your geometry, in your sketch, is as you can see, there's a box created on the outside. This box is used to create our domain so that it encompasses our actual test piece and shows and gives us space to see the wake zone. And so that's why we have this extra space on our right side. So we go ahead and generate that. And that's what we have to do for our sketching. We're going to go back to the main screen. And we're going to go into our mesh. All right, so once we get into our mesh, we're gonna right click mesh, we're gonna insert method. So once you insert the method, it's gonna take you to this body, to this selection. We're gonna select our body, hit apply, and go ahead and make sure we have quadrilateral dominant, and that should be good. Then we're gonna go into our mesh and make sure everything's good. I put it at 0.05 just to give me a reasonable, calculation. And we go ahead and go back to home, hit generate. Our mesh is now going to generate. Oh, well, we want to show our mesh. Right. 1 second. Stop this. All right, so we're going to go ahead and let that generate. And then, so as we do that, we want to make sure we have our name selections. We're going to call the inlet, this edge the inlet, our right edge of the domain as the outlet. Symmetry, we can choose the top wall for symmetry. You can choose the top or the bottom. Upper wall will be this one. Frontal wall will be the front left side of that object. Back wall will be the back side of the object. And of course, lower wall will be that last portion. So once everything's done meshing, we're going to go right back to our main page, our workbench page, I should say. And we're going to update this, make sure everything's good. Then we're going to open up our setup. So we have our Fluent launcher. We're going to make sure double precision and display mesh after reading are selected. So we go ahead and hit start. And once we hit start, we want to go to our Fluent table. And as we let it load in, one thing that's important is to make sure that we have pressure-based and a pressure-based type, our absolute velocity formulation. Once we do that, we're going to go into our models. We're going to expand models, select viscous, and for this specific project, we want to do K epsilon, standard K epsilon, select enhanced wall treatment, as well as pressure gradient effects, turn those on, and then we're going to go into materials. So once we're done with that, we want to hit OK, go into materials. We're dealing with a fluid, and our fluid is going to be air. So for the density and viscosity of air, I'd put 1 and 0.0001 kilograms meter per second for viscosity. So we're going to leave it at that. Then we're going to go in our boundary conditions, make sure that our inlet velocity is catered to our inlet boundary condition. So our inlet velocity for this case, I chose 5 meters per second, and that's what we're going to go deal with. Turbulence intensity, I left out the default of 5%, and so we're going to go ahead and hit OK. Then do a similar thing with our outlet, but we want to make sure that we're just establishing it. But our outlet pressure needs to be 0 just to make it seem as if it was a closed system. And then we're going to go hit OK. So once we do all that, we want to make sure the symmetry is in the symmetry. Yes, it is. Our walls, they're all treated as walls and no moving walls or anything like that. We want to make sure they're stationary, so they're just that, which is perfect. So now what we can do is we're going to check our reference values. Change your appropriate length and area. My length and area happens to be 2.5 meters squared and 0.5 meters. So our length is the length of the actual object here. And so then we're good with that. We want to go to initialization, just to initialize the object so we can run our test, or run our calculation, I should say. Hybrid initialization is done. So now that we have that, we're going to run our calculation. And in our run our calculations, we're going to put 1,000 iterations. We can put whatever iterations we would like, because it'll diverge anyways. Go ahead and hit calculate, let that run. And as we are letting that run, it's going to diverge to a certain point. We want to make sure that what we're looking for is found. So just to refresh, what we're looking for is our velocity contours. We want to show our velocity contours, our pressure contours, and we're also going to determine where the flow starts to separate on our 30 degrees and 60 degrees angles. So this one specifically is a 30-degree angle. We're going to figure that out. We also want to tabulate our drag forces and viscous and all that. So the way we do that is in this part right here, where we're going to go into our results. We want to go down to reports, expand reports, go to forces, and essentially we click forces, make sure that we're calculating our forces. We hit print. So in this window right here, we're going to expand this window. Let's make this a little bigger. We're going to expand this window, and as we see, we have our forces, our pressure forces, our viscous, and these are our net amounts down here. So we keep on going with that, and the next thing we're going to help us find ourselves is with our plots. So the plots are going to tell us essentially, what we want to find. So in our plot, we choose XY plot. For our default direction, we have default And then our y-axis, we're using wall fluxes, and x, like our wall shear forces, but in the x direction. And then for our x-axis, we're just going to use the curve length. Make sure that the surfaces that we're using is the upper wall, because that's where we want to, calculate our shear stresses in that x direction. So we're gonna go ahead, save plot, close this up, and this is our new plot. So right here we have everything that we need to find our just to represent what we're looking for in our forces, our all the tabulations for the forces, pressures, and viscous magnitudes. So that's where we find all of this. Now our next step is going to be going into finding the velocity contours, pressure contours, and seeing our velocity vectors, so we can visually represent where our flow separation is going to occur. So the next step will be is us going back to our workbench homepage, and in our workbench homepage, we have our results. We're gonna go to results. Everything's up to date. Good. Go to results. Once we're able to open our results up, we'll be able to proceed. So I'm gonna turn this off just to show you guys. All right, we're gonna zoom to fit. We're too zoomed in at the moment. However, so we see everything. This is really quickly. First thing we want to do is hit the contours button. Once we hit this contours button, we're going to create a new contours, call it velocity contours, just so we can identify this velocity contours. And then in this table, we put, I just put 50 contours for this essential thing. Our locations is symmetry 1 because it's our top face, and then the variable that we're using, remember, these are velocity contours, so we want to use velocity, and we're going to keep the range local. And like I said, you can put whatever amount of contours you want for this, but 50 was reasonable for this specific application. So you hit apply, and this is what your velocity contours for this specific 30-degree angle and specifications that we have is going to be. So it looks pretty cool, and we can clearly see how our velocity is, very high in this area, and then nearly zero in this little area, but we have a turbulence pocket building up here, which is pretty interesting to see. Then for our pressure contours, gonna hit that button again, name it pressure contour, so again, location symmetry 1, but the difference now is our pressure is what we're looking for. We're looking for pressure contours. Kept our contours at 50, because that's sufficient enough. So we hit apply, and then we're gonna go look at that now. So as you can see here, we can zoom in. So it's pretty interesting. You see a lot of buildup of pressure here and almost no pressure, but negative pressure essentially here. So this is all negligible pressure. But you can see a huge buildup at this incline right here, which is pretty interesting to see as well. And then the last thing we're gonna do is we're gonna find our velocity vectors. So to find vectors, we want to see our velocity vectors so we can see the flow separation. We click vectors, and once you click vectors, you're gonna be taken to this table. You name it velocity vector because again, that's what you're looking for. So this table shows up. We have our location is gonna be symmetry 1, just as the other ones were. Keep sampling at vector, reduction factor. If you want to put a reduction factor, you could. For us, we're gonna use reduction factor of 3. As you lower the number of reduction factor, the how does that go? The more vectors are generated for this specifically. So we'll just keep it at 3 because 3 is good enough for what we want. And you'll see in a moment. So we're gonna hit apply, and then this is what we're gonna see. Zoom out so we can see. Essentially, this is our velocity vectors. So very similar to what we saw with our velocity contours, but now we can specifically zoom in